Hi, in this video we are going to talk about a theoretical background for knight tour problem. So let's get started. What is a knight tour problem? A sequence of moves of a knight on a chessboard such that the knight visits every square only once. So we have to visit every cell on a chessboard exactly once without revisiting any of the chessboard cell. What is a closed tour? When the knight endpoint is the same as the starting point. The knight's tour problem is an instance of the more general Hamiltonian path problem, as you may guess. The closed knight problem is very similar to the Hamiltonian cycle problem. So there are two main solutions, the brute force approach and the backtracking. So for example, we have an 8x8 chessboard. We are there at the green cell, and how many possible moves can we have? With a knight, there are 8 possible moves. So we are going to create these moves for the x and the y coordinates, and all of them will consist 8 integers, and these will be the possible moves we have to consider on every iteration. Schwenk theorem states that for an m by n chessboard, the closed knight tour problem is always feasible unless m and n are both odds, or m is equal to 1, 2, or 4, or m is equal to 3 and n is equal to 4, 6, or 8. So, but by the way, in general, our problem is feasible. We can find a feasible solution for the knight tour problem even if we are looking for closed knight tour problems. So, okay, we may consider the brute force approach. Of course, it's not so efficient. We just generate all the possibilities and just iterate through the possibilities list and try to find the optimal one. Because there's lots of possibilities, it is not efficient. What about backtracking? We start with an empty solution matrix or a two-dimensional array. When adding a new item, we check whether adding the current item violates the problem constraints or not. So we will have an isValid method. And backtracking is quite the same as we have seen for coloring problem or Hamiltonian path problem. We will have a method that a Boolean method that checks whether the given constraints is violated or not, and we keep iterating until we violate it or not violate it. And if we violate it, then we backtrack. If no, we add the item to the solution set and go to the next item. And again, we check whether it is good, it is feasible or not. So if we have considered all the items, then we are ready. We managed to solve the problem. So this is the backtracking part, and that's what we are going to implement. Thanks for watching.